This is 2020 paper 2 question 3, so it's a bit of a geometry / trigonometry question. So what we're trying to find is the distance from F to G here, okay? So the triangle in question, I suppose, that'll help us find what that is I'll mark it in red. It's this triangle here. Okay, so it would help if we could find out information about this triangle. So this red side here might be nice to work out because we already know this triangle, which I might just show in green. So if I just show this triangle in green, or at least part of it. And the reason this one's going to be nice to work with is because we can figure out this angle here. It's going to be 180 minus 52. So this angle here is going to be 128. 128. And then in order to find this red side, we already know the angle opposite the red side, which is this 35, so that's nice. And then we want to use this distance of 6 meters, so the angle opposite that's going to help to work out this angle. So the way we can figure out this angle is we have two angles in this triangle. We know they add to 180, so 35 plus 128 plus something will give us 180, and you can do that out. So I suppose I'll just write it out fully. 35 plus 128 plus x is equal to 180. So you can subtract those two numbers from the two other sides and get that x is equal to 17. So this angle up here is going to be 17. And then we can use the sine rule because we know two angles. We know one side, we need to figure out this side. So if we use the sine rule, well, we can say sine of 17 divided by the side opposite, which is 6, will be equal to sine of 35 divided by the side opposite, which is going to be FH. So then FH, if I bring it up to the left, I can bring the 6 up as 6, and I'll have sine 35, bring the sine 17 down. We can figure out what FH is, and FH ends up being roughly 11.771. So now that we know one of the sides of this red triangle, we know this one is 11.771, we could use the sine rule again, possibly, because we have a side, we have an angle. We need a side. If we could figure out one more angle, the sine rule is going to get us to the answer. So how can we figure out the angles? Well, this angle is going to be a little difficult. If we look at this angle here, well, we haven't used the fact that this is a right angle or this 5 degrees, so maybe this is a good shout. So what you could think of doing is if we draw a line parallel to the ground, so a horizontal line, well, then that means that if we have a look here, I'll draw it in pink, we have this little Z shape. Oops, that's horribly drawn. We have this little Z shape here. So these angles are alternating. So if I draw this pink angle, that's going to be 5 degrees, okay? So that's 5 degrees. And then this is a vertical line, this is a horizontal line, so because these are parallel, this angle here is 90 degrees. So this angle in the red triangle, that's going to be 90 plus 5, so this angle is going to be 95. So hopefully that made sense. So these two are parallel. This is an alternating angle with the pink angle here, so this angle here is now going to be 95. So I'm just going to erase that now a little bit, just make things a little clearer. So this angle here is going to be 95 degrees. Now, in order to find FG, we need the angle opposite FG, which is this angle up here. So you can do a similar trick where we know the angles add to 180. So 52 plus 95 plus the angle FHG, so angle FHG, will be equal to 180. So then you can figure out that angle FHG just has to be equal to 33 when you do it out. So 33, and then this angle up here then is going to be 33. So now we can use the sine rule. So what we're looking for, we can say sine 33 divided by the side opposite, which is FG, is equal to, and then what do we want to use? Well, we want to use this 95 because we know the side opposite. So we want to say sine 95 divided by 11.771. So that means bring FG up to the right. So we'll have FG will be equal to, we'll have 11.771 sine 33 divided by sine of 95. And you can just put that into your calculator. So FG will be equal to, and you should get 6.44 meters. Or depending on how you did the rounding, you might get 6.43, but both are accepted. The reason you might get 6.43 is if you rounded this to 2 decimal places instead of 1, possibly, or just some rounding somewhere else. But yeah, it's probably 2 with this. But yeah, so that's how you can do it. Then we have this diagram, and we have to figure out the ratio of the area of S to the area of C. So basically, in order to figure out the area, we obviously need to know the radii in terms of each other, and then we just get the ratio. So the idea is we know the radius of the small circle. We need to figure out what is the radius of the big circle in terms of the small circle, and then we can find the ratio of their areas if we kind of know one radius in terms of the other. So the way that we could think of doing this is BOA, so that's this angle here, that's 60. And we can see that this angle gets cut in half here, and the reason for that is just because this diagram is symmetric. So this angle here is going to be 30 degrees, and then we have a little right angle triangle there. where this is OD, and here is a radius. We don't really know anything about this side, but it's not super important. But the hypotenuse is going to be nice. Now, you could figure out this side, but the problem is if we figure out this side, well, then we know part of this radius, but we don't know what this part here is. It's going to be difficult to find out. But if we figure out here, we know part of a radius, and then we know this is one of the smaller radii, so it's going to be quite nice. So if we want to figure out this side, I'll just call it x, and this is 30. Well, we can use sine. We can say the sine of 30 will be the opposite, which is r over the hypotenuse, which is x. Sine of 30 is a half. So that tells us that x is going to be 2r. So that's bringing x up here, bringing 2 up there. So x is 2r. So this red part here is 2r. Okay. And then this green part here is going to be r. So that means the radius of the big circle is 3r. So radius big is equal to 3r. And that's the reason we didn't want to use this piece down here, because this piece down here, it's hard to figure out what this whereas it was easy up there. So now what we can do is we can just figure out what the areas are. So big area, well, that's going to be pi r squared, which is going to be pi times 3r, the whole thing squared. I should say that this becomes pi 3r squared, so it'll be equal to 9 pi r squared. And then the small area will be pi r squared, and then r is just little r. So it's just the radius, because the radius of the small circle is just r. So what's the ratio? So the ratio of area of S to C, so S is the bigger one to the smaller one. So we have 9 pi r squared, the ratio of that to pi r squared. Well, since the left-hand side is 9 times bigger than the right-hand side, that's the same as having a ratio of 9 is to 1, where the left-hand side is 9 times bigger than the right-hand side. Another way you can think about that is ratios. You can divide both sides. So clearly the value of k is 9, because that's the number on the left when the right side is 1.